Hi, in this video I'm going to try to show you how to balance an equation, and we're going to start with some smaller numbers and move up to a few bigger numbers and just have a little look at how we can think about balancing equations. When we look at the cubes on the table now, we can see 6 add 2, 6 add 2 equals 6 add 2 equals 8, and most children will find they can do that in their head quite easily. But the trouble is, we often think that this symbol just means what's the answer? What is the answer to 6 add 2? Sometimes we have a missing number and we need to balance the equation. So it could be that 6 add 2 equals 4 add how many more? And that often really confuses children because they think of this symbol as the next number is the answer. But equals doesn't mean the next number is the answer. Equals means this side here, everything on this side is the same as everything on this side. And so you need to work out what you need to do to make these sides balance like a set of scales. So here we have 6 add 2. So this side all together is worth 8. And that is the same as 4. And then we're thinking, and what? What would we add to 4? 4 add 4 makes 8. So in this example of a balanced equation, we had an addition being the same as another addition. Okay, but we can also use some multiplication. So here I'm showing 3 lots of 2. 3 times 2. So I would write 3 times 2 equals, and we're used to saying that 3 times 2 equals 6 because 3 lots of 2 are 6. But there are other things that we can put over on this side as long as they're all worth the same. So as long as this side is worth 6. So 3 2s is also the same as 2 3s. 3 times 2 equals 2 times 3. So there isn't only one thing that you can put on one side at any one time. But what this means is it means whatever is on each side, they have to be worth the same. It's all about finding balance. And we can use some cubes or something you've got at home, like pieces of pasta, to work it out with smaller numbers. But if you've got some larger numbers, so maybe 28 add 42, is the same as something add 12, then it gets a little bit trickier to do in your head. And so this is where some written methods might come into play, or you start to be able to look at the place value to help you do some addition in your head. So here we've got 2 1s and 8 1s, that's 10 1s altogether, so that's a 10, 4 more 10s and 2 more 10s. So the 1s make a 10, plus 4 10s, that's 5 10s, and 2 more 10s, that's 7 10s. So this side is worth 70. And 70 is the same as, and what lots of children will see is they'll work this bit out, 28 add 42 equals, and they'll write 70. But what that would then say is that this side, 70, is the same as 70 add 12. But that doesn't make any sense. You can't say one side is 70 and 12 and the other side is just 70 and use equals. So it can't be 70 as a missing number. So if this side is worth 70, then this side is also worth 70. I've got 12 here. So what I can do is I can take the 12 away, and that will leave me with which number goes there, because this number plus the 12 makes 70. So if I just work backwards and take the 12 away, so 70 take away the 10, leave 60, then take away 2 more, would be 58. So actually, the number here is 58. And that shows you that both sides are 70. And as your numbers get trickier, you can start using written methods, which you should be practicing at school as well. Here's another example of balancing an equation. So here we have 43 lots of 3, 43 multiplied by 3 equals, so this is the same as having 140 subtract and there's a missing number here. Okay, so there's two parts to working this out. First of all, we need to work out what this side is worth, and then we can work out what's missing over here. So remember that this symbol literally means that both sides are worth exactly the same. Okay, both sides are worth exactly the same. Now 43 lots of 3, you might try and hold that number in your head and do 3 lots of 43, or this time I'll just show you using a quick column multiplication. So I'm going to multiply 3 lots of 3, which is 9, and then 3 lots of 4 for the tens column, 3, 4 tens, which is 12 tens. And that one's just going to come straight up because I don't have any hundreds. So this side is worth 129. So I know that this side is worth 129 because that's what that symbol means. It means they're worth the same. So over here I can look a little bit more closely. I've got 140. I have to take something away, and that will leave me with 129. If I just stopped at 140, that wouldn't be the same. This side would be bigger or heavier. I like to think of it as a set of scales. We need to make the scales balance. So what do I take away from 140 to make 129? Well, if I took 1 away, that would leave me with 139. And then if I took another 10 away, that would leave me with 129. So I took away a 1, 10 and a 1, 1. That was 11. So now both sides are worth 129. I have balanced the equation. In this example, the missing number is actually before the equals symbol. And this sometimes confuses children as well, because we're often used to seeing it on the other side. So something divided by 5 is the same as, is equal to 27 divided by 3. And so the first thing that you need to do is work out the part of the equation that you can. So we've got all of the numbers we need over here. So let's start here. 27 divided by 3. And if you know your 3 times table, you know 3 goes into 27 9 times. 27 divided by 3 is 9. So this side of the equation is worth 9. So if this was a set of scales, both sides are the same. This is 9 and this side is worth 9. But it doesn't mean that 9 divided by 5 would be the same as having 9. That wouldn't make sense. Something divided by 5 makes 9. Now sometimes it's a bit tricky to try and think what that number could be, and so our knowledge of the number operations can help. So we know that times is the opposite. So we know that something, mystery number, divided by 5, 1, 2, 3, 4, 5. So if we split a number into 5, it makes 9. 9, 9, 9. So in other words, 5 times 9 will make that mystery number. So we can use the opposite operation. We can use multiplication to work out this one. So instead of, if you don't recognise that straight away, you might do if you know your 5 times table. But if not, we can work backwards. We can do the inverse, the opposite. We can do 5 lots of 9. 5 lots of 9. If you don't know it, you can count on your fingers to 9 lots of 5. Or if you're practicing your 5 times table, you will recognise that's 45. And as soon as you put that in, that should start to make sense to you, because if you've got 45 and you divide that by 5, that gives you 9, which is the same as having 27 and dividing that by 3, which is 9. Both sides are the same.